Okay, Bismillahirrahmanirrahim. Let us look at another example given in our workbook. Solve the initial value problem for this differential equation. Initial value meaning you are supposed to find the constant given the condition when x equivalent to 1, the y is 2. Okay, let's do it together. So I'm rewriting back the question. Okay, I'm trying to combine or separate the variables, combine the x with the x, the y with the y. Okay, here we would like to get this dx as a numerator value. So hence we multiply all with dx. Okay, so hence we get x dy. Over here we have y dx, and over here we have x dx. Then let's combine the dx. So we have x plus y over dx. Over here, obviously, you cannot separate the variables. So you have to use another method instead of separating the variable. So to use the second method, using the integrating factor, okay, you have somehow to remember the steps given, okay, the guideline given. Okay. First, you have to rearrange your differential equation in this format. Okay, 1 dy dx. So this is dy dx, sorry. Okay, dy dx. And then p multiplied by the variable y and q. Alright, so when you rearrange this, then you can recognize the p. Why do we need to have the p? Because to multiply with this integrating factor in a form of a u or mu, okay, so we have to remember this formula, okay, and we have seen earlier on how we can get to this formula, right? So e power integrating px dx. P here is a function of x. Alright, then after that we are to multiply everything, okay, all the terms there with this integrating factor, and hence when we integrate on the left side, we can see that it becomes something like a product rule, and you can combine it. Okay, we can combine the product rule. Now it becomes the mu y. As we integrating this product rule, you get this version on the left side. Okay, and because of that, then you are to get the dx as a numerator value over here, bring it over here, and then you integrate both sides to get to that mu y. Alright, so you have to remember the steps. So we're going to follow this guideline. So this was the question just now. Alright, so again, as I said, you are supposed to get it in a form of dy dx and a function p times y and qx. So the guideline just now, okay, we have to get dy dx only, and then p with a y and q. So here we have x. So what we need to do in order to get the dy dx there, we need to divide all with x. So hence, as we divide all the terms with the x, so we have dy dx, okay, minus divide by dx, 1 on x, y, and on the right side, x divided by x, which is 1. Okay, so from there you can see the p. So that is the p. The p here is 1 on x. So we recognize the p. Okay, actually it's a plus, so the p has to be read as minus 1 on x. So on the marking scheme, sometimes to be able to recognize the p, we can say that this is m1, okay, or actually you are to get the integrating factor. Okay, the formula was mu. Okay, let's go back the formula. The formula of the integrating factor is e power integrating px dx. That was the formula. Okay, so we substitute the value there, where the p is negative 1 on x, okay, dx, or m1. Okay, and you are able to do this provided that you recognize what is the p. Okay, and then you have to solve this. Okay, integrating 1 on x is ln x, or actually using a property of the log, this is negative 1 ln x, so it becomes ln x power negative 1. And again, the law of the log e power ln y is y. So there we have x power 1, x power negative 1, or which is 1 on x. So we get a1 there. Okay, we have managed to get our integrating factor. Make sure that you show there's an integral that is involved there. Alright, that was step number 1. Next, step number 2. So what is step number 2? Basically, step number 2, you are supposed to multiply everything, that equation 1 with our equation 1. You have to multiply it by the our integrating factor, which is 1 on x. So over here we multiply, okay, to all the terms just now, okay, until we can get this format, right? And you see that this is an integral. You can combine it, okay, 1 on x, y. You can check it back if f is 1 on x, okay, and the y. So using the product rule, it was the fg prime plus f prime g. You can check where the f is 1 on x, the derivative of f prime. What is the f prime? So the derivative of the f prime is this one, okay, this one. So sorry, because we are multiplying, there you can see 1 over x squared. We've got that already, can this one multiplied by dy, and then if g is y, okay, g is y, so differentiating y, we get dy dx. So this equation is valid. So meaning we have to have this one. You have to be able to combine it into this part. So here I'm just trying to prove, to verify whether or not our equation here, the product rule is equivalent to this. You don't really need to show down there, so you can just erase it. This is just to prove. I'm going to erase it. Okay, so it is valid. Okay, so what we need is this portion. Okay, so I'm rewriting it back here. Okay, after you have got this, what you should do is to bring this dx on the other side, multiply everything with dx, so we have to have that, right? Okay, and then step number 3, you are supposed to integrate both sides. Remember last time we said if we have, let's say, a derivative of dx, it becomes x. Derivative of ds, it becomes s. Derivative of, let's say, theta, okay, the theta, it is theta. Yeah, so now we have a derivative of this set, okay, so which is y over x, this set that we have obtained earlier. Alright, okay, and then on the right side we are to integrate 1 on x. Okay, so there is 2 marks there given, okay, such that you are supposed to do the integral both sides, and then you are to solve it, okay, for the right hand side value, and then to get your y. Okay, okay, then we are given an initial value such that when x is 1, the y is 2. This is to replace our constants of integration. Okay, let me show you just now that way we got. Okay, we've got that, so hence it is x of this thing. So let's replace the x as 1, the y is 2, so 1, there's a bracket there. And what is the value of ln 1? We know last time, okay, basic property, ln 1 is 0. So we are left with c. So hence c is 2. Right? So we solve the c, and that will be the final c of this solution for our differential equation. Okay, let us count how many marks do this question carry. It started with you are supposed to get in this form so that you can recognize your P. Okay, after you have recognized the P, you are supposed to use this formula of integrating factor, you have to memorize this. So we replace our p there, which is negative half. Okay, m1, yeah, for you to be able to recognize into the formula of integrating factor. Okay, and then you are to solve this integration. It's very simple integration, and recognize what is your integrating factor mu. Okay, we got the A1. All right, and then after that, you are step number 2. You are supposed to multiply this equation that we have obtained just now, okay, with this integrating factor, okay, which is d1 on x. So multiply on this equation. So you carry another mark there. Okay, don't skip it. Don't skip until you are able to recognize such that this is actually the product rule. Okay, so you don't really need to write this down. Okay, so you just need to write down all this part, this portion, right? So to be able to recognize what is the U and the V, okay, or the F and the G in this case. All right. Okay, so sometimes you carry an answer there. Okay, A1 must be correct. All right, and then in order to solve for the Y, okay, we continue here. You are to rearranging, okay, multiply all with dx. So we bring the dx on the other side and integrate both sides. So m1, okay, integrating a factor of 1 over y on x is y on x, and the other side is ln x. Make sure you show your integral, and then hence you get the y as x ln of absolute x plus the constant of our integral. Okay, A1. Okay, since that the question here, he gave us the initial value, okay, a condition such that when x equivalent to 1, y is 2, for hence you are able to solve for your C and give a final answer there. So how many marks do this question carry? So this question can carry 8 marks. Okay, you do need to memorize a little bit on the technicality on how to get or how to use this integrating factor. Okay, don't stop there. Make sure you do more exercises. Thank you.